experiment, so that the statement should have been heat was not observed within so many milliwatts measurement, or are they nonlinear, in which case the whole experiment was destroyed by the error interpretation?
I think you cannot attribute any significance to the experiment unless you analyze each experiment individually and see whether you can analyze it. If the system is wired up incorrectly, then you have to throw it away. There's no point in continuing. I've continued with the analysis, and Mel has continued with the analysis, because we want to see what we can extract for those particular cells. But if you convert an error, a random error of 0.01% to a systematic error of 5%, then you should really start again.
As you know, I go to many of these meetings, and I sometimes feel my greatest contribution is to say, do good experiments. This I said in Provo many years ago, and people agreed and said, great, we'll do good experiments. And also in '93, I went into much more detail in the Maui meeting. Now, there has been great discussions. Ed Storms has been saying the technique of using the pulse of heating is not a good way to calibrate. You said yesterday that Ed was wrong, and you're going to answer him. Now, fine. But the point is you disagreed. Now, when I say do good experiments, I think once you do an experiment where you don't have these discussions, and the best way to do calorimeter is to use the Wheatstone bridge method of no, you measure, when you try and get measuring nothing, then you're safe. And this means you have a calorimeter that can take 3 baths at 30 degrees, 40 degrees, 50 degrees, and you put your thing that you believe is giving out heat in the middle one, and all the others you keep constant. This is the way that is used in Harrow, for example, when you have plutonium mixed up in a gump metal. It's very hard to separate the plutonium. So what you do, you take this little horrible mass and you put it in the middle one. You find it causes heat by the plutonium decaying, and therefore you reduce the current going into your heaters to keep the thing constant. Therefore, there's no argument about delicate calibration. You just measure, you reduce the amount of heat going in because your cell or your plutonium is giving off heat. And when you do that, you avoid all these discussions. And I would very much like to see people doing good experiment and avoiding all these discussions.
Well, you see, Douglas, it's impossible to answer you, because it would take about half an hour to answer you. Your system is actually not applicable to the system we study. You have to be very, very careful not to say you should use an isothermal calorimeter of like the plutonium type calorimetry, which is not applicable to this type of system. You have to ask yourself, what am I trying to measure? How am I going to set about measuring this and do that? I absolutely agree with you, you have to do it properly. Now, in fact, the Harrow work on the plutonium calorimetry was a complete fiasco.
Yeah.
I take about an hour to tell you why.
You have, Martin, you have access to the original, Martin, you have access to all the original data from the Japanese work. Is that what you're working from here, or you just have a tiny little snippets of it?
I've only got this one data set. I've repeatedly asked for the data set so we could assist our colleagues in evaluating the data. I've never received a reply to any of my letters.
Since my name was taken in vain, I feel I should make a comment about this so-called controversy. My remarks were more of a generic nature. It is dangerous to use a heater in an isoparabolic calorimeter. However, if you design the calorimeter carefully, and if you do the work properly, and in particular if you use the heater for heat pulse calibration, as Martin is doing, those errors are much reduced. And I'm not implying that Martin has those kinds of errors in his calorimeter. They may be there, they may be very small, but they certainly are not a major contributor to any error in his particular environment. Now, other people I cannot say that for, and I want to emphasize that if you use such calorimetry, you must be very, very careful.
Because there's electrolysis going on.
Right, the electrolysis produces different gradients because it produces different convection currents than does the heater.
No, I think this is where I disagree. If you've got gas evolution, and you can trust the two thermistors, they are within 0.01 of a degree, and the difference in temperature through the system, in fact we did this in 1989, we racked 8 thermistors to the cell. The difference in temperatures are so small that you just shouldn't bother about it, providing you have gas evolution.
That's what you're saying. You're saying the same thing.
Yes, I think so. I think that, and equally, if your heater is properly designed, you can dissipate the heat from the heater very well. And in fact, the way we use the heater, we have a much smaller injection of heat at the heater than at the cathode. So we've balanced this out as far as we are able. One other thing I should make, which is sort of oblique to what Douglas was saying. If your errors are so low, in the system are so low that in order to achieve even lower errors, you have to have a very extensive program of calibration. Then you know you have achieved the ultimate error of that system. And you shouldn't really bother to complicate your calorimetry.
If there are no further questions, we can.
Yes, I just would like to add a few words. We had a splendid dinner last night. And a number of us thought that it would be appropriate at that time to thank the organizers. I think those of you who were sitting near me realized that I was getting up several times to see whether I could arrange such acknowledgement, but it proved impossible. So I thought we agreed we should do so now. So let me just say to Antonella Denino and the secretaries and Francesco Scaramuzzi that it's been a splendid occasion. I know it's still continuing, but this is probably the last occasion on which we can express our thanks to you. It so happened that yesterday the Italian radio interviewed me in the presence of Franco. And I said, they asked me for my opinion about this meeting, and I said, it's quite clear we're moving into a second phase. There are entirely new experiments on calorimetry, which will make much of what I have said redundant. And also, as a great surprise to us, it turns out that there are a number of new phenomena which we have been pretty skeptical about. And I think that here we have to bear in mind that it is the very existence of the phenomenon of cold fusion which has made people look for very small signatures, and goodness knows where this field will take us. However, at the moment we are at this, I think, in something of a watershed, and we greatly appreciate your organizing this meeting and want to again express our thanks to you.
Thank you, Martin. Also on behalf of Antonella and all the committee that ran this conference, and that will be very well. I was just adding, it's not yet. I mean, for the conference. This afternoon we have, this afternoon we have the poster session, preceded by the poster presentation session, and tomorrow morning at 10 o'clock we have a conclusion session where I hope to see all of you. It will be followed by a branch.
Excuse me, I just had a question. I won't be here tomorrow. Maybe that's good.
That's very bad.
Yeah, I'm sorry. But I'll miss you too. I wanted to know, did you decide where the next meeting's going to be? Have they decided where the next meeting is going to be?
I can anticipate it. I was hoping to be able to give this announcement yesterday at dinner, but logistically it was almost impossible. It was
Same as I.
various places,
Logistically impossible.
some part with noise, some part with dark. we didn't have also a mic to talk to. I decided I would do it tomorrow. But since you asked me, I'm happy to say that we had a meeting of the International Advisory Committee on Tuesday, and we discussed the item, as usual, as every conference we do, for the next conference. conference, ICCF-8, and I'm happy to say that Professor Lee of the Tsinghua University of Beijing accepted to be the chairman. So next conference will be in Beijing in 2002.
Travel a little harder.
Thank you. I just say 3 words. Most of you remember, we tried to find the roadmap from Maui to Beijing. During the 7 years, we worked very hard. We obtained the help from our British friend, French friend, Japanese friends, American friends, Italian friends, and from Russia and from India. Now we have this roadmap. I believe all of you will help those who help themselves. Let's work together for ICCF-8 in Beijing.
Yeah, we were trying to. We were giving this away too. Take it.
Our first speaker for this afternoon session is Dr. Danilo, paper number 89.
Your microphone on? Turn it on.
Can you hear me? Yeah. So, it deals with the fingerprint of the interior side of the patient in the right. The experimental technique is based on X-ray absorption microscopy. This technique has the ability to probe both the electronic parameters and the local geometry of samples. The experimental layout of this work is this. There is a small cell with a sample loaded electrolytically by deuterium, and we use the XANES and XAS techniques. It is an in situ measurement. It was done in ERSF live source in Grenoble in France. 3 minutes at a very short time, but I want to show is that it was possible to do very nice measurement in which the signal is very clear and the ratio signal to noise was very good. So it is really possible to extract information from this technique. What is important is to do calculation, because the interpretation of this data is very complicated. So it is necessary to do calculations in a way that is well known to people that work in this field, to extract the characteristic, the structural characteristic, the atomic position, the lattice parameter, atomic vibration. Information are contained in the measurement. It needs a mass of calculation, a long calculation. But it is possible to extract data. This is what we are doing in this period. It is clear from the reported calculation that the technique gives us information about the site occupation.
Second paper is will be presented by Dr. Bill Collins. Paper number is 91, please.
gentlemen, it's my pleasure to read the paper prepared by Dr. Fulvio Cristoni of the University of Catania. And the title of the paper, as you can see, is The Probability of Deuteron Plasmon Fusion at Room Temperature within Microcracks of Crystalline Lattices with Deuterium Loading. The principal objective of this communication was that of demonstrating if and how the deformation of the crystalline lattice at room temperature can influence the process of fusion. In particular, we calculated the probability of fusion within a microcrack, comparing it with that calculated on the surface to evidence a possible enhancing effect. With this aim, we have identified the probability of fusion within a microcrack with the deformation coefficient gamma and performed a numerical simulation using the WKB method in the case of a model with a cubic structure. The result is that, in effect, the presence of lattice deformation enhances the probability of fusion by at least 2 or 3 orders of magnitude, compared to the case of the non-deformed lattices. And of the metals considered, it was found palladium appeared to be more effective in catalyzing fusion because of its structural characteristics, and the dependence of the process is greater in the case of an impure metal, such as 0.8% impurity. So to cross the potential barrier requires a total energy lower than the minimum value of the potential, thus enhancing the tunneling effect. Thank you very much. We've got any questions?
Next paper is will be presented by Dr. Holland. The paper number is 11.
I'm not basing my considerations on calorimeters. I'm not basing my consideration on calorimeters, but on experiments. The result from, for instance, from Miley and similar from many others, of the generation of nuclei by hydrogen in palladium, nickel, and others. Question of contamination. A similar experiment was done in Beijing. They measured the rarest of the rare earth elements produced here, clearly measured by X-ray K-shells, so no doubt. And if anyone can explain how the rarest of the rare elements could be contamination, he should come forward. Now, the second is a more complicated consideration. The exponential decay, depending on the Z number, can be used in a similar way as the similar results are well known from the element distribution in the universe. The exponent Z dash is an access to explain very much the purely numerological values of the magic numbers derived by Erich Bagge have this jump. So I don't need what Jensen and Gebhardt-Meyer had for the well-known explanation. The results here shows this immediately from this nuclear chemical reaction for this endothermic generation of these heavy elements in space and also now for us. Question, how can this happen in the metal? From earlier considerations we know that from the semi-empirical law we are in the range that we have in a distance, the nuclei hydrogen reacts in a distance of about picometers within times of 10 to 4, 10 to 6 seconds. And from this, we have then to find out why the picometer distance reaction is possible with respect to screening. And for this, we have the swimming electron layer, plasma mechanic, and the biomechanism. And we can simply say what's happening with the neutron background in supernovae or perhaps Big Bang, but I don't what happens there with neutron background happens with the 1 picometer screen protons in the
Commander, the paper number is 5.
The title of my paper is anomalous heat evolution of deuteron implanted aluminium upon electron bombardment. And this, the first slide shows this paper aims 2 points. First of all, the previously reported melting on aluminium on electron bombardment is reproducible or not, and it was reproducible. And secondly, is to measure or try to measure the neutron. Yes, try to measure neutron at the same time with the observation of the melting. And this slide shows the transmission electron microgram attached with the NE213 liquid scintillator detector. And this slide shows the typical example of melting on in deuteron implanted aluminium. These white contrast region means the segregation of or precipitation of implanted deuterium, and black contrast region is aluminium matrix, and this region is it shows the crystallization after the melting. So it is these regions are polycrystalline regions. So it means the it's the indication of melting in this experiment. And polycrystallization is evidenced by this photograph. It shows a matrix. It's an electron diffraction pattern, and with a matrix diffraction pattern and polycrystalline pattern. And this is the measure emitted radiation measurement. Emitted on the electron bombardment. The left side shows, the melted specimen, and this is not melted specimen.
The paper number is 85. I'm Dr. Wilson, and we'd like to present our comparative work with Dr. Scaramuzzi, where we obtain new data concerning correct in terms of electromagnetic noise problem measurement of DD reaction yield, in particular 3 MeV protons and a soft bremsstrahlung during high current pulse glow discharge operation, in order to exclude electromagnetic noise in the detection process. We used electronics-free solid-state detectors CR39 for charged particles and thermoluminescent crystal aluminum detectors provided with set of beryllium foils for X-ray spectra estimation. The cathodes used were 100 micron thick palladium, titanium, niobium, and tantal. And we use it in glow discharge experiment at nominal voltage ranged of 0.85 to 1.2 kiloelectron volt and current density 50 milliamps. The detectors were placed in this position under the anode, having several holes in it. So we obtain proton, 3 milliprotons yield for CR39 track detectors in the case of palladium, titanium, niobium, and no proton yield in experiment with hydrogen and in experiment with tantal with deuterium. Also, we obtain X-ray spectral estimation, from which we can conclude that effective accelerating voltage in the discharge is nominal 1 keV voltage must be 2.5 keV. Also, we obtain the X-ray image of anode cathode area with the help of obscure chamber. Our conclusions is that in the discharge, there is a normalization procedure for data of Kasagi to our points, and we. The next paper presented Dr. Kubota. The paper number is 60.
My name is Francesco Scaramuzzi from Department of Nuclear Engineering in Kobe University of Mercantile Marine. We have studied beam target interactions. A few years ago, these three-body reaction with deuteron were reported. Then the purpose of our study is 1. To clarify the condition for the enhancement. 2. Determination of the branching ratio of 3D reaction. And 3. To clarify the mechanism of the cross-section enhancement of the three-body reaction in low-energy region. To this end, we performed experiment using 1. 3 kinds of theoretic samples. 2. With full use of coincidence detection system for the reaction products. And 3. With full use of intellectual accelerator analysis of samples. An example of alpha particles measured with delta EE counter telescope system is shown here. A lot of impurities with density less than 1 ppm has been identified, and this portion could be alpha particles originating in 3D reaction. And this is our conclusions. 1. Alpha particles except these originating in during this reaction with impurities and the sequential reaction have been observed. in the energy range from about 5 to 8 MBD on the gasoline and the received sample. 2. The result of NRA using the lithium 7P alpha reaction together with the absence of the conscious partner as well as the fluence dependence of yield suggests that the portion of the spectrum from 7.4 to 8.1 MeV can be ascribed to the alpha particles originating in lithium 7P alpha reaction. And 3. On the 5 microsecond sample deployed with the 20 kV DC plus beam, alpha particles of unknown origin have been observed in the energy range from 4.8 to 8.5 MeV with a yield ratio of 10 to the negative 7 to the product. And this energy region covered by that of the alpha particles from 3D alpha PM channel. Thank you. Welcome to my poster.
Dr. Lee, the paper number is 63.
This is an experimental work, nuclear transportation in various metal hydride and deuteride. It's an international collaboration between Tsinghua University Group and the Frascati Group and Institute of New Energy Group and every retired. Dr. Denino, using preparata effect, successfully load deuterium or hydrogen into palladium with very high loading. He was so kind and sent his sample by express mail to my group. So we did the second scanning electron microscopy, trying to find the new elements. And we tried to trace all this contamination, but we found the nickel 10%. There is no contamination source yet. Then we analyzed the morphology by the backscattering electron and the secondary electron. And eventually we tried once the Raman scope because Professor Martin Freshman mentioned about Raman spectrum several times. Dr. Harold Fox is the only one who put his house in the bank to get the money to support our cold fusion paper. He used the Cincinnati cell to obtain the reduction of the gamma ray emission. So I obtained the sample from the Cincinnati cell and tried to find the new element from the original, compare the original and the final. We used the atomic emission method, and we analyzed 46 elements, and we found only 2. It was not in origin, but it's there after the electrolysis. Dr. Tom Purcell has a good resource to use the reactor to do the neutron activation analysis. So I sent my sample to him to ask his help. And he tried to screw down the reactor paper and try to have the result. Hopefully, before we writing the proceeding, we may have the result. Thank you.
Sorry about that. Next paper is by George Wiley, number 66, and a set of abstracts. George.
I don't know.
This is about the reaction products and heat correlation for low energy nuclear reactions, reactions of the hydrogenous material for the metal lattice itself. So what we're talking about is a correlation of the measured reaction product array with the measured excess heat. And I would state that this is equivalent to the similar correlations that have been talked about this meeting between helium-4 and excess heat and the types of reactions that have DD reactions as the main source. So what we're talking about is this array which I've shown several times of products that occurred in various nickel and palladium thin film experiments, and this array has many products with it. The point would be if you take a very simple but tedious calculation of taking each of the products in that array, multiplying by the binding energies, and subtracting the fuel of the elements that were burned up, and times their binding energies, you can calculate the excess power that should be produced. And that is what we've done. Now, the main issue here is what's the fuel. This assumes conservation of nucleons in order to obtain the fuel, because the fuel is not only the metal but also the protons that are burned with the metal. This creates quite a different case for the binding energy. So if you go through that calculation, this shows 3 runs where we've been able to, we have sufficient data to do that. And as you can see, the calculated values I agree within sort of the ballpark with the measured values for excess heat in these 3 runs. And I'll be glad to go through the details with you at the poster.
Next paper is by Lerici, number 41.
On the probability of collision of the nuclei, microphone. On the probability of collision of the nuclei in hydrogen and deuterium molecules. So quantum mechanics is known.
Switch. Mic's off.
Have to switch it on.
No. Oh, thank you. On the probability of collision of the nuclei in hydrogen deuterium molecules. From quantum mechanics, it is known that the wave function can be separated into another part and the part which concerns the vibration of electron motions. From the discussion of the Schrödinger equation, it is immediate to the derivation that when J, the quotational quantum number, is different from 0, psi must be 0 when R is 0. So there is no collision. The rotating molecules cannot collide. When the quantum number is 0, psi is different from 0. So in that case, it can collide. The situation is very similar to that of the hydrogen atom, in which the S electrons have no 0 probability to be on the nucleus. The point is that there is reverse order, because in the hydrogen atom, we have an attraction potential in the hydrogen molecule, we have a repulsion. But in any case, psi is not 0, but it's very small. It is interesting to see if there are any exceptions. An exception that we have is that in connection with the approaching of the nuclei, we have one of the electrons which approaches the nuclei too. Because in that case, the motion is correlated. There is a compensation of the potential energy, and there is no barrier. So it is evident that the problem of the correlation between the motion of the nuclei of the electron is extremely important with regard to the possibility of collision of the nuclei.
the mathematical procedure to take into account this kind of correlation is not simple. There are many attempts in the literature. We have tried one of these, and I don't report here this description of the procedure that we have used, but just the result. For instance, for the ground state, the probability of collision for the uncorrelated wave function is 10 to the minus 35 as the order. When it's correlated, it's 10 to the minus 21, which is much greater. Similarly, if we consider a set of successive vibrational states, the probability increases remarkably from 10 to the minus 21 to 10 to the minus 16. It still has very small quantity, of course. The deuterium is a stable gas. But anyway, we can see that the correlation between electrons and nuclei is extremely important.
Last minute went pretty fast. Next papers by Dr. Bota, previous chair.
So my title is Some Experimental Results on Heat Measurement. This report was divided by two sections. One is the precise measurement, heat measurement during electrolysis. Many papers recently presented some excess heat, but heat amount of excess is very small. So we need some more precise measurement. So we are still developing two types of flow calorimeter. The one is the Yokohama type. We are using the active wall temperature control. The other is the energy type flow calorimeter. This is vacuum insulated system. So using these, we are improving these systems. So using this system, we measure the light water system, in this case, nickel or platinum and light water and potassium carbonate system. We also measure using the metal beads, metal is the palladium, nickel, and titanium, also the light water and the lithium sulfate system. Our results for the calorimeter for the Yokohama type, I say the heat recovery is 89 to 97%, but still fluctuating. The systematic error we estimated 1.5%. For energy type, heat recovery improved to the 99%, and the systematic error should be, we estimated less than 1%. So, but unfortunately, using this method, we didn't get the large excess heat for the metal beads and light water and the lithium sulfide case. But for also the same, we cannot detect the large excess heat for the nickel light water system. However, we detected some small excess at the beginning of the electrolysis. This is one typical result. You see this is the temperature trend. At the beginning, 2 or 3 hours, we detected a little bit excess heat. So this curve is we extrapolated by using the equation. This amount is around 1700 joules. So this is a range of the chemical energy, but we cannot find any chemical reaction suited for this system. Thank you very much.
Next speaker is photo video. Paper number 94.
Good afternoon. I will present a new method which has been developed at Francesco for detection of small amounts of helium in a gas mixture, such as the one we grew up in electrolytic loading experiments. This is a schematic drawing of our facility. There is a ultra-high vacuum chamber equipped with the high-resolution mass spectrometer, which is evacuated by turbomolecular pump and the non-evaporable getter alloy pump. The idea is to exclude the turbomolecular pump during analysis of gas sample by closing this gate valve, in order to prevent the turbo pump from depleting the gas sample from its original helium content. The getter pump will provide enough pumping in the chamber to keep the vacuum in the 10 to -8 millibar range. So this gate is closed just before the gas sample is introduced in the analyzer, and the getter pump removes, or at least strongly reduces, all components of the gas mixture except for noble gases. The catalyzer and the cold trap with some absorbent material cooled down at liquid nitrogen temperature can be used in order to reduce gas load on the getter pump. This is an example of analysis of a nitrogen sample which is used for initial purging of the cell circuits. You can see that when the turbomolecular pump is excluded, the getter pump is able to keep the partial pressure in a rather small variation, so that the vacuum in the chamber is still good. When the sample is introduced in the analyzer, you can see that there is a strong increase of nitrogen, which is pumped very rapidly once the introduction of sample is stopped. Helium is not pumped by the getter pump. Okay, I will skip just to the conclusion. If I am able to find the slide. Okay, we have carried out many tests and calibration which demonstrated feasibility of this new method. More details will be available at poster.
The difference between that one beep and two beeps is less than a minute. I don't know why it isn't, but I think we're shorting these speakers just by 30 seconds.
No, it's supposed to be 30.
Oh, it is? Oh, that's the reason. I thought it was like 2 minutes and a 3.
No.
2:30? Oh, it's like, so I'm wrong. I understand correctly. Next speaker is Stringham, Roger Stringham.
I was going to report on some work at SRI doing some calorimetry on cavitation devices, but it's not ready yet, so I'm going to talk about cavitation bubbles and what's going on with their collapse processes in metal targets.
Yeah.
That's right. There we go. This is a 40 kilohertz signal. How big is the mic? This is a 40 kilohertz signal. It's input going into the bubble, which grows isothermally and then collapses pseudo-adiabatically, forming first a collapses adiabatically, forming a jet in the final stages. And this jet that's on the metal lattice will go first electrons, and then the deuterons go in, and what you have is a very high concentration of deuterons, which form an environment for fusion events. And these fusion events that occur in the lattice will produce a tremendous amount of heat, and the heat will produce these vents, and you get vaporous target metal that comes out, producing little vents that vary in size. This is 300 nanometers, so they vary in size from 25 nanometers in diameter up to around maybe 5,000 nanometers. And their distribution is very interesting because you have a peak right around 100 nanometers in diameter, and this is equivalent to about 30 MeV event. And then the others are multiple events. Finally, I'd just like to say that we do have some gaseous product analysis, and these are tritium analysis, but we do this by way of looking at helium-3, which is a product from the disintegration of tritium, and we get the tritium constant, and we produce somewhere around 10 to the 13th atoms of tritium, and I'm done. Thank you.
Thank you, Roger. Next speaker is Vasatsky, paper number 8.
Very quickly. I'd like to present the result of experimental investigation of the process of controlled transmutation of intermediate isotopes in growing biology cultures. Here is a member of our scientific collaboration from Russia and Ukraine. There are two main parts in our investigation. The first part entitled is Time-of-Flight Mass Spectroscopy, Study of Nuclear Transmutation of Intermediate mass isotopes in growing microbiological cultures. We have our investigation based on the reaction, intermediate mass isotope reaction, growing in bacterial culture Bacillus subtilis. The reaction results in generation of the rare iron-54 isotopes. In natural iron, the concentration of these isotopes is very small, about 6%. In the table you can see the contents of all components of natrium medium. These components for control experiment, and all these components for experiment for transmutation. Here is the scheme of experiment on transmutation. First experiment with the natural so-named reference experiment. It is for detecting of all position of isotopes pure and natural iron, and also two experiments for control experiments without all components of natrium medium, and experiments for transmutation with all components. On this figure you can see the result of mass of light investigation. The case 8 is the result of a mass investigation for detecting of all components of iron. It is iron 54, 56 and 57. Case 6 is the result of investigation of the culture that was grown in non-optimal case. It's also, we have the same components and also same the ratio of the iron 54 to iron 57 components, about 6%. Also case B presented the result of mass spectroscopy investigation of the culture that was grown in optimal case. In this case, the ratio of the concentration of the iron 54 to iron 57 components is equal to about 1. The average experimental coefficient of transmutation equal about 10 power minus 10 synthesized iron 57 nuclei per second and per single nucleus. Also, I would like to present the other method of the same investigation. On this figure, you can see the result of photo registration made by the screen of oscilloscope with Maybury. Also, it is the reference iron isotope. Also, it is a control experiment. It is an experiment on transmutation. Also, I would like to present the result of common Nussbauer and mass spectrometry investigation for this reaction. It is the result of Nussbauer investigation. It is the result of mass spectroscopy investigation. For all cases of investigation, we have the same coefficient of transmutation, about 10 power minus 8 per second and per 1 nucleus. Thank you.
Thank you. Next speaker, paper number 43. Come on.
In this current investigation, I'd like to show some results obtained by so-called controlled out-diffusion experiment. This shows an experiment set up in Rome. Halogen hydride were deuterium with manganese oxide film was set in the center of vacuum chamber, and a current of around several amps was followed through region for 3 hours, and gas monitoring and temperature measurement continued during 3 hours and lasted following 1 hour. Occasionally, anomalous time behavior in temperature and gas pressure were observed. This shows typical time behaviors of Q-mass currents for halogen deuterium, and there is a clear difference in time behaviors between current with mass number 4 and that of mass number 6. This difference suggests that the components of gas with mass number 6 is tritium. Of particular interest is the result of autoradiographies using normal photographic film. For example, this is a case of palladium hydride. You can see the stronger exposed part in upper fluid, which corresponding to the bandolier part of between exposed part and non-exposed part in lower fluid. It's likely that it is stronger radiation source which is produced between the native area and the film covering area on the surface of the palladium, and the radiation penetrated the sequence palladium plate. And time of flight changes reveals the production of the received. Sorry. Thank you very much.
You have to get the rest of that, this poster, downstairs. Next, finals, we have the one number 3 by Chang is not being given. That's my understanding, unless there's someone who's ready to do that. Michael Miller has the last paper of the afternoon, number 101, Deep Underground Experiment on Nuclear Reaction in Water Molecule.
Here are the authors.
Speak into the mic.
Here are the authors and participating institutions. The Joint Institute for Nuclear Research, Institute for Nuclear Research of the Russian Academy of Science. And here is the title of the book. We have performed experiments to test the hypothesis by Professor Belayev about the measurable probability of molecular nuclear transitions in the presence of so-called precision resonances in resultant nucleus products of a fusion of nuclear subsystem of a few atomic molecules. Sometimes the set is called molecular nuclear degeneration in quantum mechanical terms. Here is an example of such a case. The energy of a water molecule coincides exactly with the energy of excited state is neon 18 nucleus. Experiments with water were carried out in the deep underground laboratory of the Neutrino Observatory Caucasus. The shading was about 5 kilometers of the water equivalent. We are searching for annihilation radiation from the decay of the daughter fluorine-18, decaying by positonium emission is test beta class. Molecular spectroscopy process of water gave a possibility to use accumulation measuring sequence for separation of useful signal from the background and to identify F18. This is the procedure. This is the first experience in this two direction of the whole fusion, and we present here first results. Confidence level of 80%. The effective half-life of water to decay into neon 18 has been found to be near 10 to 18 years. The values relates to the water under the experimental conditions: 400 degrees temperature, 200 atmospheric pressure. Thank you.
That's the last paper. And, is there any announcements that need to be made? This announcement is a special session on low energy nuclear reactions, cold fusion at 2000 ISCMNS International and Nuclear Technology Expo meeting, Marriott Hotel in Washington, D.C., November 12th to 16th. You're invited to participate in a special session on this subject at the annual American Nuclear Society meeting, sponsored by the ISCMNS Accession Radiation Division. Papers or summaries are due by 15th of June 2000. There's a website that you can look at to get details on this thing. So this is from George Miley, and free to take a look at it. Any other announcements?
I got permission from Dr. Scaramuzzi to show the video documentary, Cold Fusion Fire from Water, tomorrow after the brunch. Okay, so that will be at 2 o'clock in this room. We'll show the video on the screens. Thank you.
Any other announcements?
Well, I'll call you next week and then you and Talbot.
Dave, do you want me to show this?
No, thanks.
What?
It was shown.
It was already shown.
Thanks.
If not, then we can stand adjourned.
So
very much.
well, about putting together a dump on this and then scheduling it and together with you. Oh yeah, absolutely. And in fact, the fact that that meeting is in China is going to make it challenging. Yeah, in several ways. Absolutely.
People said that they felt that it was going to go so mainstream so fast that unfortunately all of these more or less garage level shops, tinkerers so to speak, like we call them, will be forgotten and left in the dust even though they did the basic work to get it to the point where the big guys made codes. Yeah. So I mean, once the Navy got serious about it, for example, they have the resources to now to be
well, you look at the arithmetic. I mean, the government spends $80 billion plus 80 times $10 a year. Now, I'm of the opinion, and I put this in the review article.
That's DOE.
No, that's the U.S. government. All R&D. The whole DOE budget. But anyway, research. I'm of the opinion that 1 part in 10 of the fourth is money. Whether it's individual or organizational, doesn't matter.
Good morning.
$5 out of 50.
We are at the end of this conference.
10 to the minus 4 is
And I'm sorry that
10 to the 8, 9.
attended the conference had to leave, but I see that there is a good attendance yet. Let me tell you first how I planned the organization of this session. My idea is that there will be an hour of, I would call them programmed speech. I will start, and then there will be 4 colleagues from different nations that will say a comment to them. And then the second hour will be left to the floor for free comments. I would ask to everybody not to take more than 5 minutes for every comment. So let me start. And the first thing I want to do is I want to welcome in this conference Dr. Roberto Andreani, director of the Fusion Division of Enea in Frascati, not only Frascati, and Dr. Maurizio Gasparotto, who is the vice director of the same division, who kindly came to be present at the last session. In fact, Dr. Gasparotto was here with us also yesterday. A few information, practical things about manuscripts. You remember that we have a contract with the Italian Physical Society so that the proceedings of this conference can be published as a volume of the series proceedings or conferences of the nuovo cimento, Italian Journal of Physics. And we decided in the last meeting of the Science Program Committee that we would accept manuscripts and solicited manuscripts during the conference, but we also were ready to give to the attendants a little more time, and in particular up to the end of June. So I remember you that we want to have the manuscript within the end of June. Up to now we had 25 manuscripts out of the about 80 that we expect. I remember also that this should be written on the web page. The number of pages, 6 pages, all included for each paper, independent whether it is an oral or posted contribution. This deadline was chosen in order to permit to people that had some further information from the conference to keep it into account in their final manuscript. We also decided, as you probably remember, that we will submit manuscript to a referee, and this will prolong a little bit the procedure, but we hope to be able to have the manuscript, the printed proceedings by the mid-January.
mid-January. Another information I want to give you, you receive when you arrive a very crude list of participants with just name and nation. We are preparing a complete list of participants as in all conferences, but we preferred to be sure of all the participants. Thus, the list is substantially ready. What we will do is to put it on the web page as soon as we come back in Frascati, which means next week. Ask to you if you want to check that there are no mistakes. If there is any mistake, please let us know by email. We give 1 week time. After this week, we will print the list of participants and we will send by mail, not email, by mail to each of the participants to the conference.
Excuse me, will this list of names also contain the addresses?
Yeah.
Thank you.
Contain addresses, telephone numbers, email addresses, everything.
Thank you.
Whatever has been given to us, of course.
So that means 15
Well,
June.
a few data on ICCF-8. Something I already said in the opening meeting. We had about 110, something like this, proposal for communications. We have set a total of about 80. In fact, we have had a total of 26 oral presentations and I think 50 poster presentation. Somebody did not show up, so the number has been slightly decreased, and the total will be 76, so I correct my previous figure. The number of participants at the end today is 145, I mean registered participants, regularly registered participants. I just took note of the numbers for the 4 most populous countries, populous in this conference. Italy has 41 participants, USA has 38 participants, Japan has 22 participants, Russia has 12 participants. And I'm very happy in particular with this presence that has not been possible in previous conferences. So we are very happy that our Russian colleagues are here with us.
How many Ukrainians?
I want to take the occasion to thank the many persons that are permitted in the realization of this conference. The first one I want to thank is Antonella Zunino. She's been in charge of all the organization, of all the management and economic tasks, and she has done a very wonderful job. So I think that we all have to be grateful to her for her contribution. Besides, I want to thank also Maria Luisa Ciceroni, who has dedicated most of her time in the last 6, 7, 8 months to the conference and has contributed very much to its success. And the agency symposia that taken care of all the practical things like meals and coffee breaks and trips and hotel reservation, and in particular Miss Patrizia Pasolini and the 2 girls that everybody has seen, Simona and Federica. I want to remember also the Signor Bruno, who is in charge of this wonderful villa, who has been very discreetly around, but making so that everything could work fine. And I want to thank also the Enea site of Santa Teresa. We have a laboratory, a biology laboratory here, not more than 5 kilometers from here. And this Enea laboratory, in particular, it's the director, Dr. Scabia and Miss Patrizia Maffei, that you have met downstairs, have been extremely helpful for the success of the conference. Last
least, I want to thank all the chairmen that have been performed perfectly the tasks. And this time I must say that we asked them also to perform a humble task, to go around with the mic and giving it to the people that wanted to make questions. They did it very, very well, and thanks to them.
They're the only cat.
It's time for making a few comments on the conference. And I want to point out these are my comments. It's not no pretense of universal meaning what I'm going to say, but just my point of view, which can be certainly affected by partial vision. But you will forgive me. This is what I feel, and I want to communicate to you. On the other side, as I told you, the last second hour will be dedicated to comments by floor. So if anybody wants to comment, protest, to contradict what I'm saying, you're welcome. Well, I think that it was a very lively conference and rich of results. I want just to quote a few of them, because it would be impossible to go over all of them. It's not the task of my small speech to go over the whole conference. I want to put an accent on the strong confirmation that we had of the production of excess heat, helium-4, and their correlation. There were at least 3 outstanding papers. I could forget some of them. And the papers by Mike Makubre, by Professor Arata, and by Professor Takashi, which in my opinion give a very clear answer to this question. When in a certain condition, when you have a palladium cathode in a heavy water electrolytic cell, you can produce heat, and correspondingly you produce helium-4, which gives an answer very clear to the question, does it exist? First. Second, is this heat of nuclear origin? In my opinion, the answer is yes to both questions. There has been a lot of work, very, very high level, very skilled work on the so-called transmutations, which are a very large spectrum of experiments and events, which seems, in my opinion, to be growing quite well and quite steadily, and is giving another strong identification of the nuclear nature of the phenomenon that we are studying. An important task, which is a side task for the palladium programs, is the study on the charging modes and mechanisms. This has been performed in many different ways, and let me be a little chauvinist if I remember the work done in Frascati by the group that now is directed by Dr. Antonella De Nino, and who presented a very interesting results. But I quote also Celani, was interesting results on charging. This kind of presentations has shown an important and now definite trend in the research on confusion, in particular for the experiments with palladium. The use of low dimensionality subjects, low dimensionality samples. This is almost very diffused. We go from the powder of Professor Arata to the boustrophetic for shape of Dr. De Nino, to the wire of Celani, and to all this small dimension. Of course, this is very important because it makes it easier to charge, because diffusion coefficient is, however, quite low, quite small, and you need time to charge. And sometimes there are mechanisms studied in the past that prevent charging if you have bulk samples. So this is a very important field. The field of nuclear measurement is still very alive, and I really cannot judge it, because since I have not been involved in it in the last 9 years after 1991. It seems to me that there are interesting results and interesting perspectives, and I want to quote them. And then the last subject I want just to quote, as you see I'm going very, very superficially, but I want just to give hints, is the field of theories. Here we have seen a lot of theories. Very interesting, some could be questionable, but there are a lot of theories and a lot of good theoreticians are working on confusion and presenting, proposing possible interpretation. In my opinion, again, this is my opinion, I am still strongly pushed to think in terms of coherence when I think of this phenomenon. I cannot imagine, really, that a phenomenon like that of producing fusion of neutrons in an amount much, much higher than is possible in a normal system without condensed matter, and produced by the presence, catalyzed by the presence of condensed matter system, for example, the lattice of palladium, can be explained by two Boring reactions. I mean, in my opinion, we have to invoke something of collective, and then you need, at this point, to invoke a coherent behavior. And on this subject, we have had a couple of very, very interesting papers. One is the experiment of Dr. Tenino, which still aims to this. And yesterday we had a paper by Dr. Emilio Del Giudice, who explained us, which is the concept of coherence in the theory of Giuliano Preparata, which I take the occasion to remember once more. There's been present in this hall, all the conference, even though he could not be here with us. And, well, what I want to tell, it seems to me that the project of Giuliano Preparata and his co-workers is very ambitious and very important. The project does not stop at confusion. The project looks at a much more important and deep kind of revolution in physics. And I think that we're just at the beginning, and the loss of Giuliano will not help, of course, in going fast. But I would keep in mind, and I will work in that direction, and I invite you to think of it and possibly to work with it. Well, just a little consideration about where we stand in confusion. But I want to remember here the problem that is, in a certain sense, frustrating the field since the beginning, well, at least since the autumn of 1989, the skepticism of the scientific community. I don't want to remember the history. Everybody here knows the history. But the fact is that even today, the most part of the scientific community thinks that confusion is something not existing, not true, not science. And this is very strange, because things have been changing in these years. We understood not many things more. We have had much more confirmation. Reproducibility is substantially obtained. And now we have very good proofs of the nuclear nature. And papers are published also on referee journals. Not all of them. We know very well that the big journals don't accept papers on confusion, but there are many papers. I was reading yesterday a reprint of Professor Abad. There's 5 papers published on the Japanese Nuclear Society journal. And there is fusion technology with the help of Professor Miley that has published systematically papers with the use of referees. No Cimento has published papers. So it is to be, in a certain sense, rather incomprehensible, this position. And in particular, what hits me in a really strong way is the absence in this field of all Europe but Italy. Well, I should say that in France there is a group, but only one group now. There were two, only one group now active. That's all. There's nothing in Germany, nothing in Holland, nothing in Great Britain, and so on.
In Russia.
Russia, I consider one of the most, I'm sorry. But
it is not Europe.
You contradict me when I said that Russia is Europe and not Asia. You know, Russia is also Asia. Well, let's say that Russia is something out of this. Of course, Russia is very active. But this is very strange and very, very surprising. One of the reasons for me to interpret this situation is to consider another particular problem that has been debated in the last 10 years. The problem is the dualism science application. In that sense, this field has had a lot of success because it was clear to everybody that under this scientific cover there was an extremely important application topic, problem of energy. And sometimes this has had the effect of promoting too much optimism and to obtain as an effect a kind of reaction, negative reaction by the rest of the world. My position in this, I know, is not shared by many of the researchers in cold fusion, but my personal impression, my conviction is that even after 11 years, even with the conviction that we have made a lot of progress, this is still mostly a scientific problem. It is a complex scientific problem that requires a lot of work and would proceed much faster if many more people and more funds were dedicated to it. But it is mostly a scientific problem. The application to which everyone looks, including me, with extreme interest. Let's make a little statement for a future that we hope not too far. I have now no doubt that confusion means nuclear energy without nuclear emissions, which is the best mankind can expect. But let's not be too foolish and think that this can be done in 1 year or in 5 years or in 10 years. We have to face first the scientific problem with a strong effort, and then this, if it will be possible, will come out obviously very, very fast. In a certain sense, I would like to quote the example of Japan research in cold fusion as an example of what I'm saying. Japan had two very important enterprises in cold fusion. One by a private enterprise, name of IMRA, was funded by the Toyota group and has been working for 6, 7, 8 years, I don't remember exactly. And the other was funded by the government, by the MITI, Ministry of Internal Trade and International Trade and Industry. And also has worked for 4 years. Both of them are closed now. They were closed a couple of years ago. And in my opinion, the main reason, apart from the errors quoted in 2 of the papers that we heard this conference, has been the fact that these enterprises were funded with the aim of obtaining in short time very practical applications. And this was clearly not possible. So at some point they were stopped. Well, for the IMRA there was also the death of Minoru Toyota in 1993 that determined a decrease and decay in price. But in my opinion, this is what is very, very beautiful for me and surprising and fascinating is that we have 22 papers from Japan, many people from Japan here, this conference, in spite of the fact that the IMRA and MIDI enterprises have been cut down. And it's clear, you can look at them, they are almost all professors at university that have been pushed in this field by IMRA and MIDI with funds, with a big interest, and they keep the interest. They go on working, and they go on producing extremely good results. So this is, in a certain sense, I keep it as a demonstration of my theory that one should go on making mostly research, but keep in mind that there is a very important fallout, spin-off for the future. We discussed a little bit in the International Bicycle Meeting these days, and we reached the conclusion that we should probably try to have a better interaction. But I leave this topic to Jean-Paul Biberian, who will talk after. The fact is that we meet only every 1.5 years now, every 2 years. And probably this is too little. We should stay in touch a little more, communicate a little more. Well, I don't want to keep you more. Let me conclude. I want to try from this a simple message, even though I'm aware that it is not a complete message, because it does not speak of all the main, very interesting features that we have learned in this conference. There is one simple statement that can be done and can be put forward out of the world, in the world. The statement is that the production of heat by fusion is real and is of nuclear origin. This is now a certainty. I have no doubt about it, not only because I have experimented it myself, but also because I know the colleagues that obtained very good results and are presented also in this conference. So this is a message that has to be brought forward. And I think that with this message, I stop my talk and go on with the program. The person I would like to invite is Professor Miley, who has a little passion for it.
Okay.
Thank you.
I'd like to congratulate the conference organizers for a wonderful conference and superb technical interchange. I was asked to say a few comments, and I wanted to start by this schematic I drew of the start of cold fusion. The hope, as you remember, that Plunge and Flashman expressed in their initial TV conference was it would only be a year or so until we had commercial facilities. But that was something like in fission energy, when fission reactors were to produce electricity too cheap to meter, wasn't in the cards. And we hit against this non-reproducibility barrier. And I think it's clear in this conference that what has happened is that we've gone back to study of basic science in the field. And the question is then how we continue this basic science until we are again able to go forward towards applications or develop a exceedingly strong base of fundamental knowledge and understanding, which I think we are developing in the field very strongly as time goes on. It's normal in scientific fields that the basic science is supported by government foundations, and when you have government support, the information is free to everyone. And I think it's very important for us all to have free exchange of the basic science. That's so important, and I hope that John Paul is going to be talking about something he's already mentioned, ways to enhance that interchange. It's crucial. But beyond that, as one gets close to applications and practical configurations and so on, then company proprietary information becomes a barrier to exchange, but that's not the case here, and this is what we're trying to develop now. Moving on, I first want to just quickly comment on theory. We've seen good advances, improvements in systematic approaches, discussions of coherence and photo dissociation versus various particles based on neutron-type configurations that might overcome coulombic barrier restrictions. I think the challenges for theory are clear. We have to have a theory which is benchmarked against a specific key experiment, key signature. We do not yet have that. We may be close. Perhaps we're beginning to be able to correlate a theory with charged particle emission and so on. But we have to have, as the field matures, some connection between the two. Once the connection is made, then the virtue of theory from a practical point of view is it can help lead experiments and disclose new phenomena. And once that begins to happen, then we know that the field has matured. In addition to new phenomena and so on, I think the mental picture I've had now of this field is we have to have a certain loading, we have to have a certain flux and temperature dependence to have reactions occur. The question for the theory is what is the connection between loading, flux, temperature? What are the predicted trends? Experiments reproducibility, because of this earlier block, is clearly the key issue. We have to have reproducible experiments in order to do good science. At this meeting, it seemed to me that progress has been made in that direction, but I think it would be interesting in the following discussion to see how far along people think we are in doing that. I don't believe we're there quite yet. Calorimetry is a large issue, and improvements have been discussed here. And there seem to be two routes to improvements. One is increased accuracy, and that's crucial, and other people are hoping that increased accuracy won't be necessary because there will be sufficient heat that the accuracy presently available will be adequate. But progress is certainly being made on this. in particle detection and so on. We saw applications of old techniques, but very important in this field that hasn't been properly exploited yet, and that would be things like CR39 and even back to photographic film. Well, you can argue, well, there must be better ways of doing this when you have very low levels and have to time integrate over long periods of time and prevent background. These techniques are very valuable, and they're used in high energy physics and elsewhere to good advantage, and should be here too. And so we need to continue that. And certainly loading has been discussed, and methods, and then other analytic techniques, scanning electron microscopes, SIMS, and so on have been discussed and used in these challenges. I think in the first cold fusion meeting I went to, where we had a workshop to discuss what to do, the concept was we need an experiment that simultaneously in real time measures not only heat but particles, high energy radiation. We need to have an integrated experiment which has instrumentation that measures multiple quantities. And I'm afraid that that's still a key challenge, because the experiments tend still to measure only one quantity at a time and don't obtain correlations with others. Again, the maturity of a field depends upon diagnostics. We can make tremendous advances if we have improved diagnostics. And so I think we must continue to strive for more and better diagnostics that are specifically designed for these experiments. We have to have improved charged particle detectors, very small, that we can get down into the cell. We have to do things. Last night on TV, before I went to sleep, I was watching a TV camera that was in a small pill that someone swallowed and was looking at the inside of the stomach. We need things like that. Now, reproducibility I put down again as a challenge, and the challenge seems to be for cooperation in reproducibility. That is, reproducibility really can only be demonstrated if multiple labs reproduce each other's results. I did not hear one paper at this conference talk about that. It depends on, we're still trying to reproduce perhaps some of the original Pons-Flashman work, but I think the cooperation between laboratories to demonstrate reproducibility, to show that these experiments are real, has to come. Finally, I was just going to comment on the field, and we seem to have DD helium-4. We have these transmutations, or I'm calling them low-energy nuclear reactions, where you have reactions with the electrode material itself. And we haven't discussed tritium much here, but tritium has been a strong field. It seems like there are different regimes in which these phenomena occur, and the challenge is for us to understand the connection between these and the control, or what knob you twist to go from one regime to another. And I think it's more fundamental than just saying, all right, I'll change heavy water for light water and go from one regime to the other. I think you can go from one to the other using either heavy or light water. It's a more fundamental scientific issue of what is happening. And just a comment about applications and so on. I hear many people talking about so many watts and what have you, which is fine. But I think the crucial issue is still gain, but coming from hot fusion, I have that more in my mind. For example, in inertial confinement fusion, I know I want to, for a commercial laser fusion reactor, I'd like to get a gain, which would be fusion out over fusion energy, because that's an energy amplifier of about 100. And the question is, what gain do we need here? It's hard to believe you could do it with much less than about 5 for a practical case. So I think we need to shoot for 5 or so, and that is a very difficult order. And we're still down in here in papers at this meeting. We're talking about 10s and 20 and 30 and so on %. So this is a crucial issue. Now, let me emphasize, if we have a power amplifier, which is what this would be, and you put 1 watt in and get 1.2 watts out, have to recirculate part of it to keep it running, it isn't going to sell. So it has to be better than that. Now, of course, you may say, well, we'll have a gas cell that has an infinite gain. Now, we have that analogy in hot fusion too, tokamaks, which could be ignited, so to speak, and their Q will be closer to infinity than for inertial confinement. And they have other big disadvantages, namely they're big, and questions of economics. And so I don't know. We have to, this will be a tough issue to get there. Finally, I'm fascinated by the paper we had here on biological transmutations, and also some where we had transmutations with laser-induced phenomena, and some of the plasma. The symbol for this meeting was, I tried to draw it again here. We have a, anyway, I think this is a lattice, and we're envisioning, no, this is the lattice coherent picture you have, but we see so many phenomena, if they're valid, that do not seem to involve lattices. So, again, both may be true, it may be something else, but I think that ICCF-8 meeting is going to have something that looks more like this. Thank you.
That was not a caterpillar.
Proszę bardzo. Proszę bardzo.
Professor, I think that one of those microphones is not working very well. I get the impression that's
What's this guy's name, the Russian? Do you remember?
Thank you for proposing me to say some words, and if our chairman forgets that Russia is European country, I must remember all of you that Russia is a Euro-Asian country, the same as European, the same as Asian. And maybe our not rather small in this conference. I won't say some words about our Russian cold fusion in our country. I won't say you that in Russia about 20 groups works in this field of science. We have some small support from our state organization, such as our universities where we work, from Academy of Science, Russian, from our societies, Physical Society, Chemical Society, and Nuclear Society of Russia. But financial support we have maybe only from some commercial firms, and maybe such way more than half of us from our Russian delegation came here with support from these commercial firms of Russia. In Russia we have all union conferences, Russian conference on cold fusion transmutation, we named more common than fusion transmutation. All union. This year we will have the 8th conference, such as international conference 8th. We have every month seminar on cold fusions in University of Russian University of French Nations. No, it's maybe enough for our works. And I want once more thanks organizing committee from all of our Russian delegation for support and excellent accommodation in this conference. Also we have some problems and have some proposal to organizing committees. Salary. But in full, all was okay. And even weather helped us in this with this excellent, nice weather during these conferences. And in final, I want once more invite all of you from our Russian delegation to participate in our next 8th Russian conference on cold fusion and nuclear transmutation in the Kamys, Sochi, on the shore of Black Sea, in October this year. See you.
Yeah, I can't.
Your eyes aren't any better than mine.
Dr. Jean-Paul Biberian.
Good morning. It's my great pleasure to be here. I didn't have a chance to talk for the whole week, so I had a slot somewhere. First of all, I'd like to thank Dr. Scaramuzzi and all the team that organized this conference. I'm always impressed by organizers, organizing such a big, complicated thing. So thank you again. My little talk today, I'd like to emphasize a few points. One is that in 1989, when the whole thing started, there were two questions. The first one was, is cold fusion real? And second was, is there any application to cold fusion? So what happened, I will not go back into history, but the group here and other people working in the field aimed at point 2, so that means going to the application, thinking that if we have an application, everybody will believe it, Just like if Christ comes back flying from the air, everybody will believe in Christ, right? Something like that. So we were aiming at that solution. I think after 11 years, everybody here, maybe except one person, thinks we have solved point 1. So we know cold fusion is real. We are sure of that. Now, do we have to wait until point 2 to make it known, or can we go directly to use point 1 and make it known to the rest of the world? So I think we have to be more proactive. Proactive means going forward. I have a few artists in my family, and the big thing with artists, they all think that someone someday would knock at their door and say, oh, you're a great painter. They don't know that in order to be recognized, you have to go out and show your paintings, Otherwise, nobody would come to your door and say, oh, you're the greatest person in the world, This is a fairy tale kind of thing. It's called the Cinderella syndrome in the US. Cinderella syndrome means You are the young lady waiting for the prince, charming prince, to come and wake you up, you know. And we are like this here, waiting for the rest of the mankind to recognize, oh, you are great people here. You've done something great for 11 years. You deserve Nobel Prize, you deserve this, you deserve money, you deserve prestige, you deserve everything. So I don't think that will work. After all these years, I've done a few things in my life. That doesn't work. So in order to be recognized, we have to say it. So we have to say it. So we have to do a few things. First of all, there are a few things that are happening. I've been impressed that the past 2 years, the American Chemical Society, the American Physical Society, the American Nuclear Society had special sessions on cold fusion. So that's a good point. I mean, things are changing. I mean, some of the people are disappearing or something. I don't know what's happening. But some of the old ones have gone. The good thing is that the enemies of cold fusion are not that active when they retire, whereas the proactive cold fusion scientists are active even when they retire. So there's a big difference there. So who will win at the end, you know? So another important thing is that the younger generation doesn't know about cold fusion problems. You know, when you talk to a class, I have students in my class, and I talk to them about 1989, they were kids, they were in kindergarten or something like that. They don't even know there was a controversy in cold fusion. They discovered it when I tell them the story, you know, for them. And the new generation is a lot more sensitive to the environment. They don't want nuclear plants. And then in France, I know they're preparing people to build new nuclear plants, and same thing is happening in the US and elsewhere, trying to push for nuclear plants because they have no other solution. So if we come up and say, well, maybe we have a solution. We don't say we have a solution, but maybe we have a little bit of a solution. Maybe people will be more interested now. So I think things are changing, and after 11 years, also because of the solar cycle, we are 11 years back, so the nuclear will be hard. So we have a good opportunity now to do something. So we had a meeting yesterday, and we talked about the fact that there are a few things that are changing. Our good friend George Miley will quit his position as an editor of fusion technology in a few months. So I don't know what will happen with publishing in that paper. Maybe it won't be possible in the future. Maybe it will, I don't know. I don't know what Jean-Pierre Vigier is doing. I didn't see him today, this conference. I don't know if it will be the referee, it will be the head of this journal for a long time, but probably that will not last for very long anyway. So that will be the two sources of journals where we could publish, and that will be limited in the future. The other thing is that our field is an interdisciplinary field. It's not electrochemistry. It's not nuclear, it's not chemistry, it's not physics, it's a mixture. So maybe we should go in and make our own things, you know. So just like everybody else has done in the past, you know. When electrochemistry was created, they created electronic chemistry. When the nuclear science was created, they created the nuclear science thing. So we have to go to that direction too, maybe. So our discussion yesterday was to create our own journal with referees, something that would have some value. And the idea would be to have something directly electronic and not paper. So to be cheaper, faster, better. Well, it's too good to be true. So the idea would be to have a committee that we start with a scientific committee at a conference, and we start a journal that will be on the internet, and I would be the one helping on that direction. So if you have any comments or anything, we might talk about that when I finish, or the next speaker will finish, and maybe we can meet and see what we can do about it. I think that could be a gateway for cold fusion. You know, one of the problems when people want to know about cold fusion, they go on the internet like everybody else, and when they type in cold fusion, they find this company selling software. So that's amazing. It's
web-based.
But doesn't have to match. So we need something better, so that would be a reference for us to help our governments make decisions. You know, saying, oh, here there's something serious going on. Here, a homepage with papers you can read, scientific papers. Maybe we could also create an international cold fusion society, something like that, so that we know who is working in the field, who is what. And my last point would be, we need to write papers in not referee journals, because there are already many, but in journals like Nature, Science, and Physical Review level. That there are only 3 journals that are considered are really being scientific. The others are not scientific, for physicists at least, I think. And if the papers are rejected, we need to know why they are rejected. That we have to push now. I think we are ready. We have enough ammunitions now to fight back if there is any rejection, because the editors cannot reject the paper without good reasons. So we have to push in that direction. That's my opinion. So thank you very much for your attention. And,